Alright, now let's go to question number 11 and 12. It has been given a wedge which is fixed, and there is a block of mass 1 kg which is released from rest. The wedge is rough because the question says the block slides without toppling and the work done in overcoming friction up to Q is 150 joule. So when we come till Q, the work done in overcoming friction is 150 joule. We got to find speed of block at Q. Quite obviously, energy equation would be used. Work done by friction is change in kinetic energy plus change in potential energy. Work done by friction, that has been given 150 joule, so minus 150, 1/2 m v square, change in potential energy, minus mg r sine 30. And on solving this, we get the speed is 10 meter per second. So answer for question number 11 is B. And it's continued. We got to calculate normal reaction at point Q. With the help of this data, here is mg, here is normal reaction N, and quite obviously this angle is going to be 60 degree. So we can calculate by saying N minus mg cos 60 equals to mv square by r, and on calculating we'll be getting 7.5 Newton. That means answer for question number 12, that's option number A. Let's continue with question number 13. Alright, now let's go to the next comprehension, and it is from nucleus. A heavy nucleus of mass capital M can break into two light nuclei of masses M1 and M2 if M1 plus M2 is less than capital M. Quite obviously, this is where the initial rest mass energy must be greater than final rest mass energy. And same is the situation when fusion of two light nuclei takes place. The question provides the data atomic mass unit of all the given nucleus. And we have to see the question. Question number 13 says that correct statement is 6,3 lithium can emit alpha particle or not. The idea is when lithium emits alpha and the constituent, like lithium 6,3 emits alpha and the remaining constituent, that has to be 2,1H deuterium. In that situation, if we calculate the initial mass and if we calculate the final mass, in case of lithium you will find that the initial mass is less than final mass, indicating that the process is not feasible. So if we keep on checking, we find that only option number C would satisfy, where the initial mass would be greater than final mass. So we will have answer C for question number 13. Let's see question number 14 of the same part. Alright, now question number 14 says the kinetic energy in kilo electron volt of alpha particle when nucleus 210-84 polonium decays. So 210-84 polonium, when it decays to form helium, the next element you could see would be having 206, so that's going to be lead, 206-82. And here is the data given. Now we have that this nucleus will decay into its constituent. If we calculate the difference in their rest mass energy, that will be used as kinetic energy by the daughter nuclei, but owing to its small mass, it will take almost all the fraction. So the kinetic energy is very easy to calculate. Just subtract the initial rest mass energy from the final rest mass energy, and solution gives the answer very close to 5319. So therefore, answer for question number 14 would be A. Let's proceed to question number 15 and 16.